Hello, Pre-Calc students. Welcome to your next video lesson. This time we're going to be looking at section 5.1.3. Begins for you guys on page 237. Your textbooks, we're going to be going through numbers 29, 30, and 32. We're talking in this video about reciprocal functions, which basically means taking a function, for example, this f of x here, and graphing 1 over that function. Okay, so basically taking a function, putting it on the bottom of a fraction, putting a 1 on the top, and seeing what that does in terms of the graph. Okay, so we're going to start with number 29, which starts by asking us to sketch a graph of this function f of x equals x minus 3 on a set of coordinate axes. So I've done that here. This one is just a linear equation, y equals mx plus b. We've been graphing these for forever, since algebra 1. The minus 3, of course, is our y-intercept, so we'll start down at -3, and then a slope of up 1 over 1, up 1 over 1, up 1 over 1. We end up with an x-intercept also of 3, so keep that in mind as we go through this. So this is a graph of f of x equals x minus 3. Go ahead and sketch that at this point. And then we're also asked to sketch a graph of y equals 1 over f of x. And they ask us to do it on the same set of axes. So before we do start graphing it, I'm just going to show you guys essentially what that function looks like. Okay, so this idea of 1 over f of x in this particular case is really 1 over this x minus 3 that we know our f of x is equal to. Okay, so 1 over x minus 3 is essentially the graph that I'm going to be graphing. Okay, now if I just think y equals 1 over x minus 3, that should remind us of the graphs we were looking at in our last video, y equals 1 over x, and then shifting to the right or up or down, etc. Now, this particular function, 1 over x minus 3, does not have a vertical shift added at the end. So it's just our regular parent graph of 1 over x, but it has been shifted to the right by 3 because of this minus 3 here in our denominator. Okay? So if we think about graphing this function without any sort of vertical shift, but a horizontal shift of 3 units, if I think about my asymptotes, because of this shift to the right by 3, I should recognize that I am going to have a vertical asymptote here, right, at x equals 3. And I'm going to have a horizontal asymptote at the same place that it always is, at y equals 0, right, at this x-axis. That's going to be my horizontal asymptote. Okay, and then as I normally do, I'm going to just grab a couple of coordinate points. Because the top here is 1, remember that the coordinate points that I'm looking for in relation to my new origin are numbers that multiply to make this top number. So in this case, my only choices are 1 and 1. So I'm going to go ahead, and I might do this in this color. Go ahead and do this. Over 1 and up 1 is going to be right about there. And then over 1 and down 1 is going to be right about there. And then this graph is going to go, whoops, that I did not want to do. That was a little bit too big. There we go. This graph is going to go up pretty quickly along there. And it's going to go this way as well. Okay, and then the same thing here. It's going to go down along this asymptote. And then it's going to go along this asymptote as well. Okay, so there I have both of these graphs on the same set of coordinate axes. Now, a couple things that they want us to take note of here in problem 29. They say, what is the relationship between the x-intercept of the first function, this guy, and the vertical asymptote of the other? Well, hopefully we recognize that the x-intercept of the first function is here at x equals 3, and my vertical asymptote for my other function is also x equals 3. Okay, and that's going to happen all the time, you guys. When we create a reciprocal function, the vertical asymptotes of that function are always going to be wherever the x-intercepts or the 0 values were of our original function, okay? So in this case, our function was x minus 3. What value of x makes that function 0? Well, x equals 3 makes that 0. So x equals 3 becomes a vertical asymptote when I go to the reciprocal, 1 over x minus 3, okay? Also, I want you guys to notice that as these two coordinate points that I graphed here happen to be on the blue line, the original blue line, okay? Now, the only reason that that's true is because those are the values where my original function equaled 1, right? When x was 1, 2, 3, 4, my original function equaled 1. And I suppose going the other way, my original function equaled -1 when x was 2. So if I do 1 over 1, like I had here, right? When I go 1 over my x value, 1 over my y value, I keep exactly the same y value because 1 over 1 is still equal to 1. Similarly, down here, when I went 1 over -1, that just becomes -1, and that's exactly what, that's what my y value was before. When I do 1 over -1, it's still -1. Okay, so that's why these 2 points are actually on this line. Okay, and then as I go from this point, and if I were to work back towards my x-intercept, this little area, I'll give you an arrow here, this little area of blue line there from this orange point back to my x-intercept, my y values of the original function are getting smaller, right? They're getting closer to 0 as I go sort of down this blue line towards my x-intercept. So as my original function is getting smaller, my reciprocal function is actually getting bigger, because 1 over a very, very small number actually gets very, very big. 1 over a tiny number is very, very big. And that's going to be really important for us to keep in mind as we go here. Okay, so we need to think like this. If I have 1 over some tiny number, that's actually very, very big. Okay, that's actually very big, equals big. Okay, 1 over something very small is equal to something very big. So that's why we see as I come down from this orange point towards my x-intercept, what does my orange function do, my reciprocal function? It shoots up. My y value gets very, very big because my original function's y value is getting very, very small, okay? This function's getting big because the blue function's getting small. Same thing going this way. What's happening to the orange function here, my reciprocal function? It's getting smaller and smaller and smaller. Why is that? Well, because my blue function is getting bigger. Okay, my blue function is going up so that my orange function is getting smaller and smaller, closer to 0, and the same thing happens in the negative. Okay, so keep all those things in mind as we continue on here. All right, so I'm going to graph our next function for number 30. We'll move on to that here in just a second. All right, so I have graphed here our next function for number 30. Sketch the graph of the function f of x equals x squared minus 4. X squared minus 4 is a parabola that opens upward, starts at -4 on the y-axis. That means it has 2 x-intercepts at +2 and -2, which should make sense because x equals 2, x equals -2 are the 2 x values that would make that function equal 0. Right? And then they want us to consider the graph g of x equals 1 over x squared minus 4. So 1 over x squared minus 4 is basically the reciprocal function of this f of x that I've graphed here. So that idea and what we looked at in the last problem is going to help us with working through these different problems, okay? So letter A of number 30 says this function has 2 vertical asymptotes. So let's first think about g of x and where would its vertical asymptotes be? Well, it should be at whatever point the original function, the not reciprocal function, equals 0, right? The x-intercepts of the original are the vertical asymptotes of our g of x function, okay? So in that case, or in this case, we have 2 pretty clearly at +2 and at -2, okay? So here at x equals 2 and over here at x equals -2, we have 2 vertical asymptotes. X equals -2, x equals +2 are both, oops, let me move that so I can get this a little bit better. Okay, x equals 2, x equals -2. These are going to be the 2 asymptotes that we need to list for part A. Okay, x equals 2, x equals -2. And I'm actually going to move them up here probably, and I'm going to draw for myself those vertical dotted lines that I've been doing in red, just so that we can see on the graph where these vertical asymptotes are. Okay, so we do this. Generally right there and generally right here. And that's part A, okay? X equals 2, x equals -2. And now part B says, will this function have a horizontal asymptote? Well, will the function have a horizontal asymptote is basically asking, will the function approach a certain value but never actually get there? And again, think about, we're talking about this g of x function. As soon as I find my cursor, I will show you that. Here we go. Our g of x function, okay? So this function here, 1 over x squared minus 4, does it have a value that it approaches but does not cross? The answer is yes, and I want you to think about this idea right down here, that 1 over a very, very big number is a very tiny number, okay? 1 over a big number is a very tiny number. So as this x squared minus 4 gets really, really big, going this direction up here and this direction up here, the value of 1 over x squared minus 4 is actually getting very, very small, extremely close to 0. But no matter how big the original function x squared minus 4 gets, this g of x function can never be 0, right? It can never touch 0 because 1 divided by anything is always not 0, right? 1 divided into a million pieces is not equal to 0, although it may be very close. So the answer for part B is absolutely yes, it is, or it does, excuse me, have a horizontal asymptote. And the equation for that horizontal asymptote is that our y value will approach but never cross 0. Okay, so that's going to be our answer for part B. Y equals 0 is going to be a horizontal asymptote. So I'm going to go ahead and do this. I'm going to go ahead and do this, put it along here. This is going to be our horizontal asymptote, all right? Letter C says, for what values of x will g of x be positive? Well, if we think about g of x as 1 over some number, right, something, 1 over a positive number should be positive, right? So anytime our original function x squared minus 4 is positive, our reciprocal function is also positive. So there we're going to say, let's see, we would say x greater than 2 or x less than -2 would be where our function is going to be positive, right? And then the next question, where will it be negative? Well, it's exactly in between these two, right? Wherever the original function was negative, then our reciprocal function is also negative. So we would do something like this, write an inequality that says -2 less than x less than 2. Those are the values where our function is going to be negative, okay? So this is part C, this is part D right here, okay? Letter E wants us to graph this function using our calculator. We're not going to do that. We can do it by hand. So what we're going to try to think about is, okay, what's happening as this f of x function changes, okay? Now we know that we're not allowed to touch any of these red dashed lines, right? We're not allowed to touch any of those. So what I want you guys to think about is in particular this middle section here, in between the two vertical asymptotes, okay? In between these two vertical asymptotes, our function is going to remain negative, okay? And remember that as my original function approaches these x-intercepts, my reciprocal function is supposed to get very, very big, right? This is this idea. 1 over something small is something very, very big. So what we should expect to see, and what we do see, if I go here, is we see something like this, okay? So our reciprocal function g of x is somewhere up here in the negative, and then it goes down forever, getting very, very big. Okay, same thing on the other side. Same thing on the other side. It sort of comes down here like this, goes like that, goes very, very negative as our function approaches this x-intercept from the negative side. Now the question is, what's happening right here in the middle? And for that, I want you guys to think about this value right here, right? This is a y value of my original function, -4. When x was 0, y was -4, right? 0 squared minus 4. So if I go 1 over that, I end up with this y value, 1 over -4, which is -1/4, okay? So if I make that point, it's actually really, really close to 0 here. And it's important to note that the closer, or sorry, the farther negative your original x-intercept was, excuse me, y-intercept was, the closer to 0 or the smaller your reciprocal y-intercept is going to be. So once I have that, I can graph this, I can graph that. So that's what's happening in the middle section. It's sort of like an upside down parabola, sort of the reverse of what we see there. Okay, and then on these sides where my arrows are just going up forever, and I don't really have any sort of shape, I just have almost a straight line going up forever, what I'm going to see is a function that looks very much like what we were dealing with before, where it comes down and gets very close to these asymptotes. And then as it comes down here, it gets very close to this asymptote as well. Okay, so I'm not going to worry too much about where exactly you guys have these different points, because my graphs aren't perfect either. But generally speaking, as we go up forever or down forever, we'll make these graphs that look sort of like what we had before. And then anytime you're in between two vertical asymptotes, you're going to probably have an upside down parabola looking thing or a right side up parabola, depending on if you're positive or negative at that point. Okay, so we should be finished now with number 30. I'm going to call it good there for the video. I'm going to trust that you guys can hopefully figure out number 32. Where is that one going to have vertical asymptotes? There's going to be 3 of them in number 32. Where is that going to be positive, negative? Where is it going to make these whoop graphs? Where is it going to make these parabola graphs, etc.? Okay, so work on that problem and then a couple others. I think number 35, number 39 are the other ones I'm asking you to do. Submit that work to me, and that's all for this video. If you have questions, please reach out at some point, email, phone, Zoom, office hours. I'm always available for you. That's all for now. Have a wonderful day.